Wow. Okay, so today, as we take a detour from fractions, we are going to talk a little bit about number sets. Now, on the handout, don't worry too much about this thing called density, limits, and infinity. That's a next lesson that we're going to do after our assignment. First, because today's a short day and we want to break it apart, let's just get familiar with our understanding of the number system, what we currently are working with today in school. Okay, and I think I've done this picture before where I talked about natural numbers and whole numbers, and it gets bigger and bigger and bigger. A visual is you can find it on the back of this sheet. But first, again, if you want to follow me with the little multiple squares that are inside each other on the back page, you can do so. The first family, where's my little box? Okay. The first family that we're going to be working with is the natural numbers. Do you remember me talking about this story before? Right? So how much do you remember? What are the natural numbers? The numbers you learn as a baby, right? Starting from? 1. Yep. 1, 2, as far as you're able to count. And the natural numbers symbol is an N that's bolded, or if you want to try to show that it's bolded on your using pencil, just draw 2 lines before you draw your N. Yes. Sure. Have a good time. Okay. Yes. Yeah, 0 is after. So after natural numbers, we have what we call the whole numbers. And what is that? That is the concept of 0 being introduced. So let's say, when you're younger, you're just learning, you're just memorizing, you're absorbing everything like a sponge because everything is new to you. But you realize when there are things that you find valuable, like when you're a kid, a lollipop is like the greatest possession you could possibly have. Or having a big cookie is like the greatest thing you could possibly have. But when you eat that, you no longer have that cookie. And so the concept of 0 is introduced. And that's the only thing between natural numbers and whole numbers. How do you write a whole number? It's a W with 2 lines at the beginning. Like that. Sid, you with us? Is that important? Yeah. I might need more space for examples this time. The next one is what you know of as integers. And I'm going to write the symbol first. It is not capital I, as most modern textbooks will do right now in high school. Capital I is actually reserved for what we call imaginary numbers. Integers are actually Z. So it's a Z with a double slash in the middle. And the examples are anything as long as they are not decimals or fractions. We're almost there. I think I might have to move this down a little bit. There. So after integers comes rational. We will have definitions for what these are on the front of the page, okay? But rational simply means ratio, it means fractions. And how do we write rationals? I know it's weird. I want to call them the letter R, but real numbers has taken up the letter R. Rational is written as a Q. Q for quotient, because we're talking about fractions, right? A fraction is like a division, right? So we have quotient. And what is that? Anything that can be written as a fraction. So give me two random numbers, as long as they are integers, it can be written as a fraction. Like easy stuff, 1/2 is a fraction, right? 22/7, which is the closest fraction we have to the number pi, 3.14. That's also still a fraction. It's a ratio. It's a rational number. So it could be anything. It could be -99/2. Like it, I don't care. It's still a fraction. Okay. And so you see that natural numbers are a part of rational numbers, but not all rational numbers are a part of natural. Do you understand? Right? Yes.
Can every integer be a rational number?
Correct. Because integers are inside the world of rational. Long story short, if you're talking about the number -2, that is technically -2/1. It can be written as a fraction. And I need to make this box a little bit bigger because that is essentially the entire world as we know it. This is the real numbers. And I lied, it's not actually the entire world, it's 99.9% of the entire world. Okay. Real numbers, essentially any number, right? Whether it's a decimal, it could be repeating, it could be like -1.999999999, right? It could be, 0.312312312 repeating. I don't care. As long as they are repeated, as long as they either repeat or they finish. Actually, no, that's a lie. Any number. I was correct the first time. Any number. Sorry about that. How we write real numbers, it's an R. Any number out there. So I have a little box here that are still real numbers. They count as numbers, but they are not rational. They are irrational. They cannot be written. They cannot be written as a fraction. So how do we write that as a symbol? It's not Q. So how could we communicate using symbols the word not or opposite of Q? Any ideas? Sort of like the new system we saw in the video. What should we add to this to say that it's not Q? Any ideas? Be creative. An N, so like NQ? Sure. But what if you're not English? If you don't know the English language. The word not, if French, it's like ne pas, right? Like NP, like how do we keep it consistent? Sure, absolutely, we could do that. But instead of the X, mathematicians got even more lazy. What we write is a bar on top, or we put a little comma next to it. It's a prime. It's weird. I don't know. You take your pick. Some examples. Numbers that are decimal, but you can't write as a fraction or it doesn't end. Yep. Yeah. Pi is one of them. There are a lot of others though. Some are more advanced. Others you might have encountered in your journey. Square root of 2. You put it on it doesn't, as far as we know, that doesn't end. It's really too hard. Like 1.414 something. Pi is 3.14 something. There are some other numbers out there you might have heard of. Anyone heard of the golden ratio? Like human beings or living things just naturally tend to follow the golden ratio for random reasons. And we are hardwired to find it more appealing to the eyes. So if you see a plant, flower that follows the golden ratio, we find it beautiful, even if it's not symmetrical. If you're someone's face, regardless of whether they're good looking or not good looking, if they follow a certain symmetrical golden ratio, they are ready to be models for magazines because there's something about it that attracts people. It's not about whether they're good looking or bad looking. It's about symmetry. It's weird. And that, I forget the symbol of it. I'll just write golden ratio. The golden ratio is like a 1.6 something, 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 right? So your eyes to the space between your eyes is a 1 to 1.6 ratio, right? The space from your eyes and like the length of it from your like this side to this side, a 1 to 1.6 ratio. Then you're like you're the distance from your eyes to your nose and the nose to your lips, a 1 to 1.6. It's crazy how the math goes in. Another number that you can look at is Euler's constant. And that I believe is a 2.7 blah, 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 blah. There's lots of irrational numbers out there. And that's as far as you need to know. But if there are real numbers, what's the opposite of real numbers? Unreal. Anyone know an example of an unreal number? Well, maybe. That's technically an idea. Well, I guess that's an idea too. Yeah, they might fall into that. That's above my pay grade. I'm not quite sure. What I know for sure is the letter I, which is a number that stands for the square root of a negative value. And mathematically, that doesn't exist. You can't square root a negative value. But if you could, we actually apply this and solve lots of interesting mysteries in physics and space. That's the thing. If you could, then amazing things could be done with it. And I know it's a little hard to wrap your head around. I want to show you an interesting comic. I'm not sure if I could find it, but I hope I have enough time to waste like this. Comic, unreal versus irrational. Wonder if I'll find it. No, I don't think I can find it. Anyways, it's basically something like this, where pi and I are arguing against each other. No? Okay, never mind. I'll just keep moving. Anyways, let's get on to filling out these definitions for your own reference. And then from there, you can do some of these examples to wrap your head around it as practice. Okay, yes, sure, go ahead. Okay, let's do it. Nice. Okay, so I'm going to do some very quick definitions. You don't have to get way too in detail. Just follow along with me. Natural numbers, any non-decimal positive numbers. All okay. So essentially natural numbers are all positive numbers. I'm going to specify all the way to infinity for as far as you can count without decimals. So it would be 1, 2, dot, 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 all the way to infinity. Whole numbers, instead of giving you a mathematical equation, I'm going to say they are basically natural numbers plus 0.
0 is zero is not natural, right?
0 is not a natural number. And I'll write n here. Okay. integers, all non-decimal numbers, all non-decimal numbers. Okay, and that would be integers being a z. That is negative infinity, negative 1, 0, 1 to positive infinity. Rational numbers, again, if you can write it as a fraction using integers, it's irrational, okay? All ratios and that is e.g. P divided by Q. If you can write it as a number divided by another number, where both of them are integers, you got yourself a rational number. And rational is Q for quotient, Q for a division. Some examples, I think I wrote 1/2, negative 22/7, positive, 129/3. I don't know, anything that can be written as a fraction. Irrational, essentially, irrational can't be written, cannot be expressed as P/Q. Depends on what the square root is. If it's the square root of 4, like one of the examples or questions are in the back, that equals 2. So that would be a integer. Yes. And that would be irrational. I'm just going to do this because that's what I was sort of shown, but you can do the comma too if you want to. And some examples of irrational that cannot be written as a fraction. Pi, square root of 2, Euler's constant, golden ratio, all of that jazz. Please note one thing, for irrational numbers, you know that it's decimals that won't stop. Rational numbers could be decimals that go on forever, but it's repetitive. Let me give you an example. If I gave you 1/3, 1/3 can be written as a fraction, but it's also this. So a rational number, even though it's a repeating and it doesn't end, it still counts. So another definition you can write for rational numbers is a either terminating or repeating decimal. So I'll also write either a repeating or terminating decimal. Those also work. And then of course, real numbers is any real number, any number. And that is there. And for examples, I'll just say not I. The rest is pretty good. So today's exercise, and I'm basically there, I'm done. We're gonna try that first chart together on the back of the page. And then the rest you can do for homework. I will give you a quick reminder of what you can expect for the assignment after, so don't just leave. We're gonna do the first part together. We just did that together.
Where's that say?
You don't have to, I guess, but it's there and good for reference. Yes, Ellie? At 50. So we got 20 minutes. Here we go. 0. 0 is not a number you learn as a baby, not yet. But it does start from whole numbers, which means it's a part of integers, which means it's a part of rational numbers. Will? You keep that up, you're going to have a problem. Please check yourself. Natural number, again, fractions. That should automatically ring a bell. Fractions is a ratio. So it doesn't count for any of these. It only accounts for rational. Be careful of the next one. 3.4, point something, point anything is not what you're taught as a baby. It's not a whole number. I think the name gives it away. Is it an integer? No decimals. Is it a rational? Yes, 0.4 can be expressed as a fraction. If you weren't sure, that is essentially 34 over 10 or 17 over 5. It can be written as a fraction, and so it is a rational. 1 is all 4. -3. You don't know negatives until integers get get introduced. Square root of 4 is a 2. Or, let's see how much you know. Whoa. That could be a +2 or a -2. 2 times 2 is 4. -2 times -2, 4. And so it could be a positive or a negative. The answer would be integers. That's a tough one. Put a little star next to that because it'll come back up probably in grade 10. Negative decimal. Already, you know that it's a decimal, so it's not integers. But 0.4 can be expressed as a fraction. If you weren't sure, that is 4 over 10, which is also equal to 2 over 5. And the same way, the very last example is also a ratio, it's a fraction. So there it is. You might need some time to process all of these checks. I did it relatively fast. If number sets are new to you, well, I don't expect you to go at the speed that I did, but I wanted you to know that there was a way to process and think about each number. Just take your time if it's hard. Try the remaining bottom and finish it off before you leave today. And I will talk about what to expect for tomorrow at 1:45. Any questions about this? All right, that's all we have. If you're done early and you still feel like you can do some of you probably didn't finish all the fraction questions from yesterday, that's always available to you tonight. All right.